Now let us look at the second example for in the buckling analysis. We have a circular arc of rectangular cross section and it is subjected to a pressure load as shown in the figure. So the pressure getting applied on this face is 1 megapascal. The boundary conditions are also given over here. Both the edges over here are fixed support. Okay, and now we have to find out the load multiplier for the first buckling mode. The material that is going to be used for this arc is stainless steel, and the arc cross section is 5 into 50 mm. 5 mm into 50 mm. Mean radius of the arc is 50 mm, and the included angle is 90 degrees. Okay, so now in this condition you can see that as per the dimensions are given, the thickness of the model is very small. So rather than creating this as a 3D model, we can consider this to be a 2D model. Okay, so let us see how to perform this analysis in Ansys Workbench. So let us add the static structural analysis system. The material that we have to use for this analysis is stainless steel. So I will come into engineering data, resources, general materials, stainless steel, and we will add this. Okay, now we will return back to the project and we will again come into the geometry. Now once you come to the geometry, observe the unit system. It is into mm. So set your unit systems to millimeter, and now start creating your geometry. So the geometry, we have to create a circular arch of radius 50 millimeters. Okay, so I will take one arc option. Okay, I will give the dimension, and the radius is 50 mm. Once this is done, I will draw two lines from here. And the angle between these two has to be let me calculate the angle again. This has to be 90 degrees. And now I'm going to use one constraint symmetry in this. Once this is done, I will trim whatever is not needed. Okay, and I will give one more constraint. Okay. Let me delete this. So this is the arc that we wanted. Okay, so we got the design. Let us come to the modeling tab, and now I'm going to extrude this. Now while extrusion, the depth given is 50 mm again. Okay, so this is the model that we needed, and the thickness of this model is supposed to be 5 mm. Okay, you can also view the model like this. Now once the design is ready, we've understood that instead of 3D model, we are going to consider it as a 2D model and solve it. So the design is ready. We will come to Ansys Workbench project schematic window, and now we will enter into the mechanical window. So the material has to change to stainless steel. So once you change the material to stainless steel, the next is we need to mesh the model. So I will just use the default mesh settings and perform the meshing. So you can see that the meshing has been done. If you wish, you can just change the relevance so that the meshing becomes finer. Okay. And now we will click on the static structural node and give the supports. So we need fixed support on both the edges, which have been applied now. After this, I'm going to again click on static structural node, loads, and we are going to apply a pressure on the top surface, and it is 1 megapascal. And let us solve the analysis. I'm not taking any results because I'm not interested into the static structural results. After the static structural analysis is done, we can exit from here. And the next, we are going to add the linear buckling analysis system to the solution of static structure. So now you will see all the data is shared. You will click on the setup. Okay. Analysis setting, check the number of modes to find, and now solve the analysis. So the analysis is done, and we have also got the load multiplier, which is 587.52. So when I apply this to the pressure, which is 1 unit, that means if I apply a pressure of 587.52 megapascal, this design over here will buckle. Okay, and for this load factor or the load multiplier, if I create the deformed shape, this is the deformation that we will get, and you can perform you can generate the animation for this. So this is the method of performing a buckling analysis on a 2D model.